You're watching the final episode of your favorite show. The villain just revealed their master plan. The hero's about to make their move. And then boom, spinning wheel of death. Your video freezes, and you're sitting there staring at a loading circle like some kind of digital hostage. Here's what drives me crazy about this. You're paying for high-speed internet. Your provider promised you lightning-fast downloads. The speed test you just ran shows everything's fine. So why is your video still buffering like it's 2005? Here's what nobody tells you about internet speed. That number your provider advertises, it's not actually measuring what you think it's measuring. And the reason your video keeps freezing has almost nothing to do with how fast your internet is. What's really happening involves a system so different from what most people imagine that once you understand it, you'll never think about the internet the same way again. In the next 15 minutes, you're going to understand exactly why buffering happens. Not the fake explanation everyone gives you about slow internet. The real engineering reason involving thousands of tiny packages, delivery timing, and a waiting room inside your device that's trying desperately to keep up. Picture this scenario. You're streaming a movie on Netflix. Everything's working perfectly. Then your roommate starts a video call. Suddenly your movie stutters. The quality drops. That spinning circle appears. You check your internet speed, still fast. So what just happened? Here's what everyone tells you. Your internet is too slow, or too many people are using it. And sure, that sounds logical. More users equals slower speed, right? But that's not actually what's happening. Your internet speed hasn't changed at all. The highway is still the same width. So why did adding one video call destroy your movie? Think about it this way. When you picture the internet, you probably imagine something like a water pipe. Data flows through like water. More users means less water pressure for everyone. Faster internet means bigger pipes. Slower internet means smaller pipes. That's the mental model most people have. But here's the thing that might shock you. The internet doesn't work like water pipes at all. Not even close. It's actually way weirder than that. And understanding how it really works is the key to understanding why your video buffers at the worst possible moments. What's really happening when you stream a video? Your computer isn't receiving a continuous stream of data like water flowing through a pipe. Instead, imagine thousands of tiny delivery trucks. Each truck carries a small box. Inside each box is a piece of your video, maybe 0.2 seconds worth. These trucks are driving from Netflix's warehouse all the way to your house, constantly, hundreds of them per second. These boxes are called data packets. And this is where everything gets interesting. Because your video isn't being delivered as one big file, it's being chopped up into thousands of tiny pieces. Each piece gets wrapped in its own little package, and each package has to make its own journey across the internet to reach you. Now, here's where the delivery truck analogy becomes crucial. These trucks don't all take the same route. They don't all arrive at the same time. Some trucks hit traffic, some take shortcuts. Some get lost entirely and have to be resent. And your device has to receive all these packages and put them back together in the correct order to play your video smoothly. This matters because when your video buffers, it's usually not because the trucks are moving slowly. It's because the trucks aren't arriving on schedule. And there's a massive difference between those two problems. Let me introduce you to something called latency. Most people call it ping if they're into gaming, but latency is basically the delivery time for each truck. It's not about how much stuff the truck can carry. It's about how long the journey takes from Netflix's warehouse to your living room. Here's the crazy part. You could have the fastest internet in the world, massive bandwidth, huge capacity, but if your latency is bad, your video still buffers. It's like having a 12-lane highway between Los Angeles and New York, but every truck still takes 3 days to make the trip. Sure, you can fit lots of trucks on that highway, but if each delivery takes forever, you're still waiting. Think about it like this. Bandwidth is the width of the highway. It determines how many trucks can drive side by side. More bandwidth means more lanes, but latency is the speed limit and the distance. It determines how long each individual truck takes to complete its journey. And here's what most people don't realize. For video streaming, latency often matters way more than bandwidth. Your video player is expecting packets to arrive at a steady rhythm. Packet arrives, plays for 0.2 seconds, next packet arrives, plays for 0.2 seconds, over and over. When the rhythm is steady, everything's smooth. But when packets start arriving late or out of order, that's when you get buffering. This is why your internet can test at 100 megabits per second and still buffer. The test is measuring bandwidth, how wide the highway is. It's not measuring latency, how long each delivery takes. And for streaming, consistent timing beats raw speed every single time. Now let's talk about that waiting room I mentioned. Your device actually has a clever system to deal with this packet timing problem. It's called a buffer, and it's basically a small storage area where incoming packets wait before being played. Here's how it works. When you first hit play on a video, your device doesn't start playing immediately. It waits a few seconds. During those seconds, it's collecting packets, building up a cushion. Think of it like a waiting room at a doctor's office. Patients arrive at different times, but there's a room where they can wait so the doctor sees them in order without gaps. The buffer does the same thing for your video. Packets arrive at slightly different times. Some early, some late. But as long as the buffer has packets waiting, your video plays smoothly. The buffer absorbs the timing variations. It's the shock absorber between the chaotic internet and your smooth viewing experience. But here's where things get sneaky. The buffer only works if it stays ahead of the video playback. Imagine the buffer is like a reservoir. Water flows in from packets arriving, water flows out to play the video. As long as there's water in the reservoir, everything's fine. But if the incoming water slows down too much, the reservoir empties. And when the reservoir runs dry, you get that spinning circle. This is why buffering happens. It's not that your internet suddenly got slow, it's that the packet delivery became inconsistent. Maybe a few packets got delayed, maybe some got lost and had to be resent. Your buffer tried to absorb the irregularity, but it couldn't keep up. The waiting room emptied out, and now your video has nothing to play. And here's what makes this particularly frustrating. The buffer is trying to predict the future. It's asking, how many packets do I need to store to handle variations in delivery time? Too small a buffer, and any little hiccup causes buffering. Too large a buffer, and you get that long startup delay before videos begin playing. Netflix has to make a choice. Start playing quickly with a small buffer and risk buffering later, or make you wait longer up front with a large buffer for smoother playback. There's no perfect answer. It's always a trade-off between startup time and stability. Now let's talk about what happens when your roommate starts that video call. Remember, your bandwidth hasn't changed. The highway is still the same width, but now there are way more trucks trying to use it. Video call trucks mixed with Netflix trucks, and this is where something called congestion happens. Congestion doesn't slow down the trucks. The highway still allows the same speeds, but it does something worse. It creates traffic jams. And in traffic jams, delivery timing becomes unpredictable. Some trucks get through quickly, others get stuck waiting. The steady rhythm your video player depends on gets disrupted. Your buffer tries to compensate. It stores extra packets to smooth out the timing. But if the congestion is bad enough, packets arrive so irregularly that the buffer can't keep up. It empties out faster than it fills. And boom, spinning wheel. This is why video buffers, even when speed tests show your internet is fine. The test measures maximum capacity under ideal conditions. It doesn't measure timing consistency under real-world congestion. It's like measuring highway capacity with no other cars on the road. Sure, it can fit 12 lanes of traffic, but what happens during rush hour? Here's another pattern most people miss. Sometimes packets just disappear completely. They get lost in transit. This is called packet loss, and it's incredibly common even on good networks. Think about our delivery truck analogy. Sometimes a truck breaks down. Sometimes it takes a wrong turn. Sometimes it literally just vanishes into thin air. When this happens, your device notices a packet is missing. It has packets 15, 16, and 18. But where's 17? Now your device has to send a message back to Netflix saying, hey, I didn't get packet 17, send it again. Netflix sends it again. But this whole process takes time. And while you're waiting for that one missing packet, all the packets after it have to wait too, because videos have to play in order. This creates a cascading delay. One lost packet causes everything after it to pause. The buffer starts draining because new packets are stuck waiting for that one missing piece. And if the buffer drains completely before the missing packet arrives and gets processed, you guessed it, buffering. Packet loss is why your video sometimes buffers, even when nothing else is using your internet. Even a 1% packet loss rate means 1 out of every 100 packages goes missing. And recovering from each loss creates delays that drain your buffer. It adds up faster than you'd think. Now here's where the psychology gets interesting. Your brain evolved to notice patterns and disruptions. When you're watching a movie, your brain predicts what happens next. It anticipates the flow of the story. And when the video buffers, it's not just annoying, it's cognitively jarring. Your prediction was wrong. Your pattern got interrupted. This is why buffering feels so much worse than just waiting for a video to load. Loading is expected waiting. You're mentally prepared for it. But buffering is unexpected interruption. You thought the video was playing. You were immersed in the story. And suddenly you're yanked back to reality, staring at a spinning circle. Your brain treats unexpected interruptions as potential threats. Back when we were hunting and gathering, unexpected disruptions and patterns could mean danger. That rustling in the bushes was supposed to be wind, but it stopped. That's a pattern interruption. Better pay attention. And even though buffering isn't dangerous, your brain still has that same negative reaction to broken expectations. But here's what nobody wants to admit about modern internet infrastructure. The system wasn't really designed for video streaming. It was designed in the 1970s for sending emails and documents. Small files that didn't need perfect timing. If an email took an extra second to arrive, nobody cared. But video is completely different. Video demands consistent, real-time delivery of massive amounts of data. And we're trying to do this on a system that was built for a completely different purpose. It's like trying to use the postal service to have a live conversation. Sure, you can technically send letters back and forth, but it's not what the system was designed for. The internet protocols we use today, TCP and IP, were created when the biggest concern was making sure data arrived at all, not whether it arrived on time. Packet loss was common on old networks, so the system was designed to be reliable through retransmission, not fast through perfect timing. And this is why streaming services have gotten so good at compression and adaptive quality. They're working around fundamental limitations of the system. Netflix doesn't send you one quality level. It sends you whatever quality level your current network conditions can consistently handle. When conditions get worse, quality drops. When conditions improve, quality increases. You've probably noticed this. Video starts crystal clear. Then suddenly, it looks like it was filmed with a potato. That's Netflix detecting packet delays and packet loss. It's making a split-second decision to lower the quality so fewer packets are needed. Better to show you a blurry video that plays smoothly than a sharp video that keeps buffering. Let me tell you about two people watching the same movie on Netflix. Sarah's in her apartment in Seattle. She's got a 100 megabit internet connection from Comcast. The speed test shows 95 megabits. She's thrilled with her fast internet. She starts her movie and immediately gets buffering. The video keeps stopping. The quality keeps changing. She's frustrated because her internet is supposed to be fast. Now meet Marcus. Marcus lives in a small town in Montana. He's got a 50 megabit connection from a local provider. Half the speed of Sarah's internet, but when Marcus watches the same movie, it plays perfectly. No buffering, consistent quality, smooth experience from start to finish. What's the difference? Sarah's connection has high bandwidth but terrible latency and packet loss. She's far from Netflix's servers. Her packets have to travel through congested networks in a major city. Lots of bandwidth, but inconsistent delivery timing. Her buffer can't stay full because packets arrive erratically. Marcus has lower bandwidth, but excellent latency and near zero packet loss. He's actually closer to one of Netflix's regional servers. His packets take a more direct route through less congested networks. Fewer lanes on his highway, but the trucks arrive like clockwork. His buffer stays comfortably full because delivery timing is predictable. Notice how the person with slower internet had a better experience? That's because streaming video cares more about consistency than capacity. It's not about how much data can theoretically flow. It's about how reliably the data flows in practice. Here's what most people don't realize about their internet connection. The path your data takes isn't direct. When you watch Netflix, your packets don't go straight from their server to your house. They hop through dozens of different networks. Each hop is a potential point of delay or packet loss. It's like planning a cross-country road trip with mandatory stops at 30 different rest areas. Even if the roads between stops are perfect, you're dependent on conditions at each rest stop. One congested rest stop creates delays for your entire journey. And you have no control over which rest stops you use. The internet's routing decides that automatically. This is why some people have great Netflix performance but terrible YouTube performance, or vice versa. Different services have servers in different locations. The path your packets take to Netflix might be clean and direct. The path to YouTube might route through congested networks. Same internet connection, different paths, different experiences. So what's really going on when your video buffers? It's not actually about your internet being too slow, it's about data packets being tiny delivery trucks. They're driving from the server to your house, they're supposed to arrive at a steady rhythm. Your buffer is a waiting room that smooths out timing variations. But when packets get delayed or lost, the buffer drains. And when it runs dry, you get that spinning circle. The people who have smooth streaming don't necessarily have faster internet. They have more consistent internet, lower latency, less packet loss, more direct routing. These factors matter way more than the raw speed number your provider advertises. It's not about being lucky with your internet provider. It's about understanding what actually affects streaming quality. And once you see it this way, the solution becomes obvious. It's not about paying for faster speeds. It's about finding a connection with consistent packet delivery, low latency, minimal loss, direct routing. So here's what we've uncovered about buffering. Your video gets chopped into thousands of tiny packets. Each packet is like a delivery truck making a journey to your house. The buffer is a waiting room that smooths out variations in arrival timing. When packets get delayed or lost, the buffer drains. And when it empties, you get buffering even if your internet is technically fast. The question isn't whether you have fast internet. The question is whether your packets arrive consistently. Because buffering isn't about speed, it's about rhythm. It's about timing. It's about getting those delivery trucks to arrive like clockwork instead of in random bursts. And now you know why speed tests don't predict buffering. They measure bandwidth, the width of the highway, but streaming needs latency, the delivery time, it needs packet loss, how many trucks get lost, it needs consistent timing that raw speed can't measure. So next time your video buffers, don't just blame slow internet. Ask yourself, are my packets arriving consistently? Is my latency low? Am I losing packets along the way? Because once you see buffering as a packet timing problem instead of a speed problem, everything looks different.